Hey everyone, so this will be our chapter 9 of Capstone project. Standards, constraint, and trade-offs in software engineering and software design. Standards, constraint, and trade-offs in software design, of course, in a normal oral examination or defense of computing students, one of the frequently asked question in this is this: what programming language or developing tool did you use? The student answered, "Sir, our group used Visual Basic, Java, and so on and so forth because this is the only developing tool that our teachers taught us." This answer is not responsive to the question. This should not be that case. Even if the curriculum includes several programming languages, the choice of a developing tool should include an explanation by students in a way that demonstrate his comprehension of the trade-offs involved in the design, including the choice of programming languages or design choices. This chapter discuss, or at the end of the chapter, the student is expected to recall different standards used in the software design and development, apply mathematical foundations, algorithmic principles, and computer science theory in the modeling and design of the computer-related system in a way that demonstrate comprehension of the trade-offs involved in the design choices. It is for computer science program. It is also design information system in terms of general quality attributes and possible trade-offs presented within the given requirements for information system program. Design computer-based systems, processes, components of programs to meet desired needs and requirements under various constraints. And of course, to function effectively on teams, to accomplish a common goal, and to write appropriately the chapter 2 and 3 of a thesis or capstone project. A standard, of course, is a document that provides requirements, specification, guidelines, or characteristic that can be used consistently to ensure that materials, products, processes, and services are fit for their purpose. So, if software was designed and developed in accordance to standards, it stands to conclude that the software product is fit for its purpose. A good method and methodology in a thesis or capstone project should therefore state clearly that the software developed was made in accordance with a standard. We have a lot of standards to be used in software design. The two main development methodologies are agile and waterfall. They are commonly applied to software development and thus project management as well. The main difference between agile and waterfall is that waterfall projects are completed sequentially, whereas agile projects are completely iteratively in cycle. And of course, one of the first decisions we face for each of our project implementation at Zige.com is which development methodology should we use? And this is a topic that gets a lot of discussion and often heated in debate, especially during our defense. If this is not something you've worked with before, a definition of development methodology is, in order put very simply, it's a way of organizing the work of software development. This is not about a style of project management or a specific technical approach, although you will often hear these terms all thrown together or used interchangeably. Again, as I mentioned, the two basic, of course, most popular methodologies are waterfall, which might be more properly called as the traditional approach, and the agile, a specific type of rapid application development and newer than waterfall but not that new, which is often implemented using Scrum. Both of these are usable, mature methodologies. Having been involved in software development projects for a long time, and I will give you later on the strengths and weaknesses of each. The waterfall model methodology. Okay? Waterfall is a linear approach to software development. Of course, in this methodology, the sequence of events is something like, of course, gather and document requirements, design, code and unit test, perform system testing, perform user acceptance testing or UAT, fix any issues, and deliver the finished product. In a true waterfall development project, each of these represent a distinct stages of software development, and each stage generally finishes before the next one can begin. There is also typically a stage gate before each. So for example, requirements must be reviewed and approved by the customer before design can begin. This will be the first software development methodologies. Example, were hardly methodologies at all, but a free-for-all as organizations struggled to profit from new computers-related technologies. As the industry learned more about developing software, certain techniques for managing and predicting the cost of software development projects came into use. The methodology that was dominated software development projects for decades is called a waterfall. Winston Royce coined the term in 1970 to describe a serial method for managing software projects through the 5 stages. So as what we have here, the first stage, of course, is the requirements, product requirements document. We have the design, the software architecture, the implementation, of course, the software, verification of your project, and of course, maintenance. There are good things and, of course, negative about the waterfall approach. On the positive side or advantage of the use of waterfall approach, developers and customers agree on what will be delivered early in the development life cycle. And of course, this makes planning and designing more straightforward. Number two, progress is more easily measured as the full scope of the work is known in advance. Throughout the development effort, it's possible for various members of the team to be involved or to continue with other work, depending on the active pace of the project. So for example, business analysts can learn about and document what needs to be done while the developers are working on other projects. Tester can prepare test scripts from requirements documentation while coding is underway. Except for reviews, approval, status meetings, and others, a customer presence is not strictly required after the requirements phase because design is completed early in the development lifecycle. This approach lends itself to projects where multiple software components must be designed. It's of course sometimes in parallel for integration with external system. And finally, the software can be designed completely and more carefully based on what or more complete understanding of all software deliverables. And this provides a better software design with less likelihood of the piecemeal effect, a development phenomenon that can occur as pieces of code are defined and subsequently added to an application where they may or not fit well. Here are some issues we have encountered using a pure waterfall approach, or the disadvantage or the negative part of a waterfall model. One area which almost always falls short is the effectiveness of requirements. Gathering and documenting requirements in a way that is meaningful to a customer is often the most difficult part of the software development. Customers are sometimes intimidated by details and specific details provided early in the project are required with this approach. In addition, customers are not always able to visualize an application from a requirements document. Wireframes and mock-ups can help, but there's no question that more end users have some difficulty putting these elements together with written requirements to arrive at a good picture of what they will be getting. Another potential drawback of pure waterfall development model is the possibility that the customer will be dissatisfied with their delivered software product. As all deliverables are based upon documented requirements, our customers may not see what will be delivered until it's almost finished. By that time, changes can be difficult and costly to implement. The agile methodology. Agile is an iterative, theme-based approach to development, and this approach emphasizes the rapid delivery of an application in a complete functional components. Rather than creating tasks and schedules, all time is time-boxed into phases called sprints. Each sprint has a defined duration, of course, usually in a week yan, with a running list of deliverables. Plan at the start of the sprint, deliverables are prioritized by business value as determined by the customer. One of the most important differences between the Agile and Waterfall approaches is that Waterfall features distinct phases with the checkpoints and deliverables at each phase, while Agile methods have iterations rather than phases. The output of each iteration is working code that can be used to evaluate and respond to changing and evolving user requirements. Waterfall assumes that it's possible to have perfect understanding of the requirements from the start. But in software development, stakeholders often don't know what they want and can articulate their requirements. With waterfall development, rarely delivers what the customer wants, even if it is what the customer asks for. The agile methodologies embrace iteration as I mentioned. Small teams work together with stakeholders to define quick prototypes, proof of concepts, or other visual means to describe the problem to be solved. The team defines the requirements for the iteration, develops the code, and defines and runs integrated test scripts, and the user verify the results. Verification occurs much earlier in the development process than it would that than it would with waterfall, allowing stakeholders to fine-tune requirements while they're still relatively easy to change. Here is some additional advantages of the agile approach that are easy to see. The customer has frequent and early opportunities to see the work being delivered and to make decisions in changes through the development process. Okay, some advantages of the agile approach are easy to see. Again, the customer has frequent and early opportunities to see the work being delivered and to make decisions and changes throughout the development project. The customer gains a strong sense of ownership by working extensively and directly with the project team throughout the project. If time to market for a specific application is greater concern than releasing a full feature set, at initial launch, Agile can more quickly produce a basic version of working software which can be built upon in successive iteration. Another thing, development is often more user-focused, likely a result of more and frequent direction from the customer. For more agile development benefits, of course, is to be more flexible enough in adjusting some additional requirements from the customers or from the stakeholders. This will be our, maybe the disadvantages of using agile development methodologies. The very high degree of customer involvement, while great for the project, may present problem for some customers who simply may not have the time or interest for this type of participation. Agile works best when members of the development team are completely dedicated to the project. Because Agile focuses on time-boxed delivery and frequent reprioritization or reprioritization. It's possible that some items set for delivery will not be completed within the allotted time frame. Additional sprints, or that maybe that is beyond those initially planned, no, may be needed, adding to the project cost. In addition, the customer involvement often leads to additional features requested throughout the project. Again, this can add to the overall time and cost of the implementation. The close working relationship in an agile project are easiest to manage when the team members are located in the same physical space, which is be a good challenge at present since we are in a pandemic, which is not always possible. However, there are a variety of ways to handle this issue, such as webcams, collaboration tools, and others. The iterative nature of agile development may lead to a frequent refactoring if the full scope of the system is not considered in the initial architecture and design. Without this refactoring, the system can suffer from reduction in overall quality, and this becomes more pronounced in a larger scale implementation or with systems that include a high level of integration. In making the choice between agile and waterfall, maybe you're asking, no? So how do we choose? First, we change the game a little, which is what most software development organizations do by defining our own process. Based on SIGE, it's called our process frameworks, and it's a variation on the traditional waterfall methodology. Our modification include use of prototyping where possible to provide the customer a better view of their finished product early in the design or development cycle. This helps to improve the team's understanding of requirements and communication with the customer. After the primary framework of the application is completed per high-level requirements, we continue to develop and also to reach out to the customer for refinement of requirements. In this way, we strive to be as iterative as possible without compromising overall system architecture. We have here, okay, the alignment project trait in development technologies. Okay, so as what we have here, project trait factor, we have customer availability, scope features, and feature prioritization. So we have an agile approach, plan-driven, and a comments. We have also a team, of course, funding and summary. So we have a data or information related to this. Now, another thing, of course, the purpose of the ISO 9126 standard and to give detailed description of a software quality model used by this standard. When we say ISO 9126, it is an international standard for the evaluation of software. The standard is divided into 4 parts, which addresses respectively the following subjects: quality model, external matrix, internal matrix, and quality in use matrix. The ISO 9126, referred to as ISO 9126-1, is an extension of previous work done by ISO or done by McCall and Boehm in 1978, and FARPS and others is defining a set of software quality characteristics. Okay, FARPS. What is FARPS? Now, later on. The ISO 9126-1 represent the latest and ongoing research into characterizing software for the purposes of software quality control, software quality assurance, and software process improvement, or SPI. It defines the characteristic identified by ISO 9126-1 and the parts of ISO 9126 concerning matrix or measurements for these characteristics are essential for SQC, SQA, and SPI. But the main concern of this, of course, is to define the basic ISO 9126 quality model. The ISO 9126 documentation of course about the quality model established in the first part of the standard of ISO 9126-1 classifies software quality in a structured set of factors. And of course, the ISO 9126 software quality model identifies these 6 quality characteristics. Again, namely functionality, a set of attributes that bear on the existing of a set of functions and their specific properties. These characteristics are broken down into sub-characteristics. A high-level table, later on, I will show you in the next slide. It is the sub-characteristic level that measurement for SPI will occur. And the main characteristic of the ISO 9126-1 quality model also discussed earlier. Now, functionality. Functionality is the essential purpose of any product or service. For certain items, this is relatively easy to define. For example, a ship's anchor has to function of holding a ship at the given location. The more function a product has, example, an ATM machine, then the more complicated it becomes to define its functionality. For reference, a sales order system should also provide the following functions. For example, record sales order, product, price, and quantity. Calculate total price, calculate appropriate sales tax, calculate date available to ship based on inventory, and generate purchase orders when stock falls below a given threshold. The list goes on, but the main point to note is that functionality is expressed as a totality essential functions that the software product provides. It is also important to note that the presence of or absence of these functions in a software product can be verified as either existing or not, in that it is Boolean. Okay, either a yes or no answer. The other software characteristic listed, of course, is discussed later. The reliability. Once a software system is functioning as specified and deliver the reliability characteristic defines the capability of the system to maintain its service provision under defined conditions for defined periods of time. Another, of course, is the usability. Usability only exists when with regards to functionality and refers to this ease of use for a given function. So, for example, a function of an ATM machine is to dispense cash as requested, placing common amounts on the screen for selection. So, for example, 500 or 100, 200, 500, 1,000, and others, does not impact the functions of the ATM but addresses the usability of the function. The ability to learn how to use a system or the learnability is also a major sub-characteristic of usability. Another, of course, is the efficiency. This characteristics is concerned with the system resources used when providing the required functionality. The amount of disk space, memory, network, and others provide a good indication of these characteristics. As with a number of these characteristics, there are overlaps. For example, the usability of a system is influenced by the system performance, in that if a system takes 3 hours to respond, the system would not be easy to use, although the essential issue is a performance or efficiency characteristics. The next one, of course, is the maintainability. The ability to identify and fix a fault within a software component is what the maintainability characteristic addresses. In order software quality models, this characteristic is referenced as supportability, because maintainability is impacted by code readability or complexity as well as modularization. Anything that helps with identifying the cause of a fault and then fixing the fault is the concern of maintainability. Also, the ability to verify or to test a system, example, that stability is one of the sub-characteristic of maintainability. And the last one is the portability. This characteristic refers to how well the software can adapt to changes in each environment or with each requirements. The sub-characteristic of these characteristics include adaptability. Object-oriented design and implementation practices can contribute to the extent of which or to which this characteristic is present in a given system. So for functionality, actually this will be the table characteristic of and sub-characteristic for the ISO 9126-1 quality model. So as what we have here, what will be the characteristic will be the functionality. The sub-characteristic, suitability, accurateness, interoperability, compliance, and security. And at the right side, we could able to see the definition. For suitability, this is the essential functionality characteristic and refers to the appropriateness or the specification of the functions of the software. For accurateness, we need to check. This refers to the correctness of the functions. An ATM may provide a cash dispensing function, but is the amount correct? Interoperability. A given software components or system does not typically function in isolation, and this sub-characteristic concern the ability of a software components to interact with other components or a system. Another sub-characteristic of a functionality is where the compliance, where appropriate certain industry or government laws and guidelines need to be complied with. Example, SOX, this sub-characteristic addresses the compliant capability of a software. And security. The sub-characteristic relates to unauthorized access to the software functions. So the next characteristic, of course, is the reliability. The sub-characteristic, of course, is maturity, fault tolerance, and recoverability. Maturity, of course, this sub-characteristic concern frequency of failure to the system. The fault tolerance is the ability of software to withstand and recover, of course, from component or environmental failure. And for recoverability, ability to bring back a failed system to full operation, including data and network connection. Next will be the usability. We have understandability, wherein it determines the ease of which the system functions can be understood, relates to user mental models in human-computer interaction methods. Learnability, learning effort for different users, for novice, expert, and casual, and others. And of course, the operability, an ability of the software to be easily operated by a given user in a given environment. Of course, for efficiency, time behavior characterizes response times for a given throughput, and of course, transition rate. We're looking for a transition rate. And resource behavior characterizes resource use, for example, memory, the central processing unit, the disk, and network usage. Okay, so the continuation, another characteristic is maintainability. Analyzability characterizes the ability to identify the root cause of a failure within the system or software. The sub-characteristic changeability is a characterized the amount of effort to change a system. And for stability, characterize the sensitivity to change of given system, that is the negative impact that may be caused by system changes. And of course, it must be testability. Characterizes the effort needed to verify or to test a system change. And the last one, of course, is the portability. The sub-characteristic under portability, of course, number one is adaptability. It characterizes the ability of the system to change to new specification or operating environments. For instability, it characterizes the effort required to install the software. And for conformance, it's similar to compliance for functionality, but this characteristic relates to portability. One example would be OpenSQL conformance. For replaceability, characterize the plug-and-play aspect of software components, that is how easy is it to exchange a given software component within a specified environment. Of course, in ISO 9126, for the most part, the overall structure of ISO 9126-1 is similar to past model, McCall, and Boehm, although there are a couple of notable differences. Compliance comes under the functionality characteristic, and this can be attributed to government, as I mentioned earlier. And many requirements note that with ISO 9126, the compliance is seen as a functional characteristics. Using the ISO 9126 or any other quality model for derivation of system requirements brings clarity of definition of purpose and operating capability. So for example, a rules engine approach to compliance would enable greater adaptability should the compliance rules change. The functionality for compliance could be implemented in other ways, but these other implementation methods may not produce as strong an adaptability characteristics as a rules or some other component-based architecture. Also, a designer typically will need to make trade-offs between two or more characteristics when designing the system. Consider highly modularized code, and this code is usually easy to maintain. Example, has a good changeability characteristic, but may not perform as well for CPU resource as unstructured program code. On a similar vein, a normalized database may not perform as well as a not normalized database. These trade-offs need to be identified so that informed design decisions can be made. Although ISO 9126-1 is the latest proposal for a useful quality model of software characteristics, it is unlikely to be the last. One thing is certain, the requirements including compliance and operating environment of software will be continually changing, and with this change will come the continuing search to find useful characteristics and facilitate measurement and control to the software production process. Of course, we have the UML. UML stands for Unified Modeling Language. It is a general-purpose modeling language in the field of software engineering, which is designed to provide a standard way to visualize the design of a system. It was created and developed by Grady Bosch, Ivar Jacobson, and James Rothbald and Rational Software during 1994 to 1995, with further development led by them through 1996. The Unified Modeling Language, or UML, offers a way to visualize a system architectural blueprints in a diagram. Although originally intended solely for object-oriented design documentation, the Unified Modeling Language, or UML, has been extended to cover a larger set of design documentation and been found useful in many contexts. And of course, a detailed discussion on this standard is covered in one full course such as software engineering or systems quality assurance. In choosing what standards to be applied in the software designs, the researcher or designer should justify that the standard had been chosen is the most appropriate. Constraint and trades-off in software design. One of the student outcomes of the computing and engineering programs required by internationally agreed upon frameworks and mechanism, particularly the Washington and Seoul Accords, is that by the time of the graduation, a student must be able to apply mathematical foundation, algorithmic principles, and computer science theory in the modeling and design computer-based system in a way that demonstrates comprehension of the trade-offs involved in design choices. Design a system, component, or process to meet desired needs within. What will be the constraint in design of PCOS source code? PCOS stands for Present Count Optical Scanner. And all Filipino are very familiar with this. The issue of PCOS, especially the IT practitioner. It is a machine that reads voted based on pencil markings on a special type of paper. Suppose you will design the code that will run on the PCOS machine. If a voter elected only 10 senators instead of 12, will you design a code which will allow PCOS machine to invalidate the vote? Of course, the answer, as given by the book of Dr. Lavinia, the answer here is a good example of a constraint, particularly legal constraint. Our election laws allow us to vote for a maximum of 12 senators, meaning to say we can vote for less than 12 if we want to. Hence, the source code should not invalidate your vote. Conversely, voting for 13 senators will invalidate all the votes we cast for senators. This is due to the fact that there is no way for a machine to discern who, from the list of 13 senators voted for, is the least choice of the citizen who voted. Therefore, the machine has to invalidate all the voted casted for senators. Validating the 13 votes will give the voter undue favor of voting 13 senators, wherein the law only allows a maximum of 12. The trade-offs. Trade-offs are needed in a situation in which one must choose between or balance two or more things, or the constraint, that are opposite, contracting, or difficult to attain at the same time. A trade-off or trade-off is a situation that involves losing one quality or aspect of something in return for gaining another quality or aspect. It often implies a decision to be made with full comprehension of both the upside and downside of a particular choice. The term is also used in an evolutionary context, in which case the selection process acts as the decision makers. The design trade-offs. Architecture is the blueprint of software, depending on the constraint and operational environment of the software. Various choices about the software's functionality, about the implementations, and about capabilities are made by architects. Requirements and constraints of the software force and architects to, at times, settle for a solution that gets the task accomplished but may not create the best possible outcome. Architects may also try to strike a balance to reconcile conflicting requirements, such as balancing acts, sacrifice, and weakens one aspect of the software to strengthen another. And this is what we refer to as design trade-offs. For example, for easy understanding, let us have a general illustration. Suppose you will design a vehicle and the constraint that you will consider are cost and environmental or environment friendly. If cost has the higher order of priority, then it most likely that the vehicle will run using a diesel fuel. Conversely, if the environmental factors is the first priority, the vehicle should be designed to run using unleaded gasoline. Trade-offs involves in designing. As rule, the best algorithm must be adapted in software design, but this is not always the case. Let us assume we have to design two algorithms. To the mind of the programmer, he can design the most efficient algorithms but will take some of his time, or an algorithm that gets the job done but may not be reusable by some other program module. Take note that both algorithms will give the same correct results. Which algorithm will you choose? For naming convention, let's name the first algorithm as the best algorithm and the second algorithm as the second algorithm. Again, both algorithms can get the job done and free from bugs. The only difference is that the best algorithm is making an efficient use of resources and run significantly faster than the second algorithm. Both algorithms are yet to and run significantly faster be done. Which algorithm should be chosen, the second or the best algorithm? The performance versus memory. Another classic trade-off example of performance versus usage of memory. Normally, performance jumps down if less memory is available and improves only if there will be more memory. So, if one is to design a game for mobile application, designer may choose algorithm that is resource intensive if the price of memory is not an issue. Otherwise, designer may choose algorithm that is less reliant from resources. We have here a system trade-offs. A trade-off or trade-off is a situation that involves losing one quality or aspect of something in return for gaining another quality or aspect. It often implies a decision to be made with full comprehension of both the upside and downside of particular choice. The term is also used in an evolutionary context, in which case the selection process acts as the decision maker. A game development. We have technical issues. For technical issues in developing a game for performance, the laptop or PC speed must be at least 2.10 gigahertz. Deployment, Android Phone version 2.3 or higher. For operational characteristic, to develop in laptop, PC, RAM, or random access memory of at least 2 gig and video card of 2 gig. For interoperability with other technologies, it can be developed with Unity Game Development version 2.6 or higher. The developers tested the game in a laptop with a lower specification than the laptop which was used during the developmental and noticed a slower performance of the application. The developers used laptop with higher specs or specification because the game can run smooth and reduces lag if the performance is higher. In creating a game set of skills and knowledge are needed. The developers use different support tools such as Photoshop CS3, Java Eclipse, Unity Game Engine, and Autodesk 3ds Max. Developers must be knowledgeable in creating design and character modeling. Creating a game is not just finishing it. It's also about how the lessons are presented. The appeal of the design, colors, sounds or audio, videos, and the combination of the technical skills and creativity used by the developers to acquire the needed requirements for the game. For operational issues, we have super tools, of course, user and developer skills, processes, and documentation. So, as what we have here, for the trade-offs, again, as I mentioned earlier, okay, so at least the developers has a knowledge on the following. And research all about game development such as theme, gameplay, strategies, term, and rules must be observed. For economic issues, no, we have here that the development cost covers up the instrument used in the deployment of the game. The developers use unaffordable flash drive that is 8 gigabytes scan disk. The flash drive cost is 600 pesos. The operational costs cover up the electrical bill, food, and transportation fee is spent by the developers during the brainstorming and development of the application with a total cost, for example, of 3,000. Collaboration and team effort in the research and design process must be observed. Under international standards, a graduate of any computing program must attain the following, among others, by the time of graduation. All institutions, colleges, and universities stated that they wanted their graduate to apply knowledge of computing and mathematics appropriate to the discipline, to analyze a problem and identify and define the computing requirements appropriate to its solution, to design, implement, and evaluate a computer-based system, process, components, or program to meet its desired needs, and to function effectively on teams to accomplish a common goal. The equivalent of student outcomes in CMO 53 series of 2006 are the following competence: teamwork and collaborative skills, conflict resolution, planning, and organizing skills. Hence, nowadays, thesis in Capstone project should be done in a group. This is to allow the students to function effectively on teams to accomplish common goals. And this student outcome was included in the new policy standard guidelines for computing programs to be released in very soon. In a real-time situation, development of a system requires a team effort. One of the industry desired attribute is that an employee must be a team player and must exercise leadership skills. Hence, if a student has programming, design, and communication skills, both oral and written, but was not able to influence his team members to do their part in the project, he does not possess the said leadership skills written between the lines of our student outcome. Considering the two extremes of collaboration. A collaboration always implies people working together toward a goal, but it is believed that collaboration actually works as being somewhere between two extremes. One extreme is very immediate and intimate. Collaboration, where writers collaborate extremely closely, literally sitting together in front of the computer keyboard or the pad of paper and going over each sentence of each paragraph together. The advantages of this very close collaboration include an equal and immediate sense for everyone involved about how the project is going. Writing projects that are more seamless, that is, all of the different parts if together clearly as one complete text, and a greater sense by individual within a group of their rules, since all the group members are working together in the same time and place. Actually, there is disadvantages of the type of collaboration. It includes hard workers. In the group might represent the group members who do not seem to contribute an equal part. Or some members of the group might feel they are being silenced and manipulated by more forceful group members. It can be difficult to coordinate times and places to meet, and it is extremely time-consuming, especially if the group is collaborating on creating a more detailed writing a project. The other extreme of collaboration is very distant collaboration, where writers divide up the labor of particular project into smaller tasks that can be then assigned to a member of the group and put together later assembly line fashion. Some advantages of this type of collaboration include: it is easy to set up tasks so each group member has the opportunity to contribute equally without duplicating the work of others. It can be done with few, if any, meetings where all the group members need to be present. And tasks can be accomplished quickly since all group members are simultaneously working on their parts of the project. The disadvantages, of course, is Because it is being done in parts, the completed project may seem disjointed and uneven. It can be difficult to manage this sort of collaboration since the individual part of the project have to somehow be put together, and usually by a group leader, someone who is named by the others, or someone who takes on the role. And there can be resentment within the group, either from leaders who other members of the group feel are doing a poor job, or of those within the group perceived as not doing their share of the work. Where most collaborative projects end up on the collaboration spectrum depend on the nature of the collaborative task. For example, things like in-class peer review of each other's rough drafts, in-class reading and writing assignments, or shorter collaborative writing projects tend to end up closer to very immediate and intimate collaboration. Things like collaborative research writing projects, research-oriented website, or other longer and more detailed writing projects tend to be closer to the very distant collaboration side of the spectrum. Clearly, one sort of collaboration isn't automatically better than another. It depends on your purposes. The best approach to any collaborative project is to be conscious of the strengths and weaknesses of both sides of the collaborative spectrum and strive to emphasize the strength of the approach within which you are working. So for example, one way to avoid some of the pitfalls of the very immediate and intimate types of collaboration is to make sure that each member of the group has a clear sense of their role in the writing project and is allowed to contribute. Conversely, the disadvantages of very distant types of collaboration might be avoided if members of the group strive to work on producing writing in a similar style and if there is frequent communication among their group members. This will be our references for this chapter. Outcomes-based practical guide to thesis and capstone project writing in computing by Lavinia and Group. Practical guide for writing ITA research project, of course, by Sumulong, Abante, and Balahadja. Of course, the www.sqa.net and www.sigatech.com. Thank you very much for listening and watching, and good luck to each and everyone. Now, you could able to do your standard, constraint, and trade-offs in your software design. I think that you can able to write appropriately the chapter 2 of a thesis or your capstone project. Good luck everyone and Godspeed.